Okay, last subtopic for this chapter, which is on centripetal force. So in this subtopic, you need to be able to explain centripetal acceleration. So we have centripetal acceleration and centripetal force. So this centripetal ni maksudnya the acceleration and force that is present during the uniform circular motion lah. So lastly, we have to be able to solve problems related to centripetal force for uniform circular motion, that which includes horizontal circular motion, vertical circular motion, and lastly conical pendulum. So you don't have to know how to solve for bank curve lah. I don't actually remember what is a bank curve punya problem. Okay, so now centripetal acceleration or can also be written as, also known as radial acceleration. Okay, so symbol dia AC ataupun AR lah. So it is defined as the acceleration of an object moving in a circular path whose direction is towards the center of the circular path, and the magnitude is equal to the square of the speed divided by the radius. That is basically telling you the formula, this one. Okay, so that is the formula. Okay, so the acceleration, what you need to know is that the acceleration is always directed towards the center. Okay, so it is always directed towards the center and it is perpendicular to the velocity lah. Okay, always perpendicular to the linear velocity. Okay, I have to say that because nanti kamu pergi cakap angular velocity pula. Okay, so directed towards the center of the circle and always perpendicular to the linear velocity. Okay, so in uniform circular motion, an object moves at a constant speed will have an acceleration. Okay, so why do this object have what we call centripetal acceleration? Okay, so since the object is moving in a circle with constant speed, the direction is continually changing with time. Okay, so although the magnitude of the velocity is constant, the direction is still changing. So because there is a change in velocity and acceleration, terbingung saya sebab dia ada, because there is a change in the velocity and acceleration, and because this velocity is changing towards the center, the acceleration will also be pointing towards the center of the circle. Okay, so because of this change in velocity, this centripetal acceleration pun present and it is pointing towards the center lah. Okay, so the acceleration has a constant magnitude tapi the direction is changing now. Okay, and the linear velocity and the acceleration is always perpendicular. Okay, I repeat sudah tadi. Okay, so that is on radial acceleration. So make sure you write down AR ataupun AC ya, sebab jangan kamu tulis A saja. This is the linear acceleration. We want the radial acceleration. Okay, now centripetal force pula. Centripetal force, which is Fc. So from Newton's second law of motion, a force must be associated with the centripetal acceleration. Okay, so bila ada acceleration, there will be a force, and then bila tu object ada mass, they will be experiencing a force lah. Okay, so that is, the force is centripetal force, which is F equal to ma. Alright, so therefore an object moving in circle must have a force applied to it in order for it to keep moving in that circle. Okay, so untuk dia move constantly swinging, supaya dia constantly swinging, dia mesti ada satu force yang cause it to move. Okay, so because of this force, the force is necessary to give to centripetal acceleration lah. Okay, so centripetal acceleration tu ada hanya bila ada force macam tu. Alright, so we can apply Newton's second law of Newton's second law to this circular motion. So kita dapatlah satu formula that is related to radial acceleration and the linear velocity lah. Okay, so remember the force is moving towards the center of the circle. Okay, so the net force required to keep the object moving in a circle is always directed towards the center of the circle, and then the net force, this force here, causes a centripetal acceleration. Okay, bila ada force baru kita ada centripetal acceleration. Bila ada force baru kita boleh ada movement circular. Okay, movement circular yang ada constant speed magnitude yang sama lah. Okay, so this centripetal force is defined as the net force acting on a body of mass, causing it to move in circular path of radius with constant speed, in which the direction of the centripetal force is towards the center of the circular path lah. Okay, so this net force that acts on the body adalah the reason why the object is moving in circular path of radius r. Okay, it is moving with a constant speed, tapi dia punya velocity keeps on changing due to the change in direction. Okay, so please remember, although the speed is constant, the velocity is not constant due to the fact that direction is changing. Okay, so if the direction is constantly changing, the velocity is also changing. Okay, so since we have the linear velocity equal to r omega, we can then write the centripetal force punya formula to be equal to this one shown here. Okay, so yang ini adalah formula untuk linear velocity. The relationship between, this is the relationship between tangential velocity and angular velocity ya. So macam nak mana lah tau kamu bingung. So this is apa tu? Linear velocity relationship dengan angular velocity. Okay, so that is the formula. And then what else? Okay, so please note that the centripetal force is not a new kind of force. Okay, so this centripetal force is just a term that is used to describe the direction of the net force lah. So the direction kamu tahu juga, it is towards the center of the circular path. So any force or components that act along the radius towards atau away from the center of the circle, away kali ni kan. Away. Okay, I'll have to edit that. Or away from the center of the circle can be centripetal force. Okay, contohnya kalau ada car moving in a circular path, we call it as friction. Kita tidak panggil dia centripetal force. Bukan an additional lah. Contohnya kamu mau lukiskan. Contohnya this one. Ini adalah kita punya, usually we call this tension lah kan. So we call this tension. Lepas tu kamu pergi tulis lagi sini, satu lagi FC. No, it is not a new kind of force. Force yang kamu belajar dalam lukisan free body diagram adalah yang Miss sudah bagi hari tu. Okay, so it is just telling you, it is just a term lah untuk describe the direction of the force. Okay, so for example, untuk car moving in a circular path, we have friction. Swinging a ball at the end of a string, we have tension, gravitational force between the planets and moon, and then we have normal force, which is force that exists when something is in contact lah. Okay, so if there is no more centripetal force acting on the object, what will happen to the object? Okay, contohnya kalau tiba-tiba kamu tidak kuat sudah, the force yang kamu buat tu kasih pusing-pusing tu stop sudah, dia tidak akan ada any circular motion sudahlah. Okay, tapi kalau contohnya sekarang ni the string is cut ataupun snap. Okay, kalau the string is cut ataupun snap, the centripetal force will disappear. Okay, sekarang ni force, radial force ni, no, we call it centripetal force je lah. The centripetal force will disappear. Okay, kalau dia sudah disappear, what will happen to the motion? The object will continue its motion in a straight path lah, in the direction of velocity, which is tangential to the circle. Okay, so they stop and continue in a straight line lah. Okay, kalau dia contohnya, kalau dia break time di sini, dia akan ke sini. Kalau dia break time di sini, dia akan ke sini. Macam tu lah maksudnya. Okay, okay, so apa yang kamu perlu faham di sini? Kamu perlu faham yang circular motion ni akan hanya wujud bila ada centripetal force. Kalau dia tiada centripetal force sudah, dia tidak akan bergerak in a circular motion sudah. Dia tidak akan bergerak lah circular motion. Tidak dapat sudah. Okay, alright. So is there any work done by the centripetal force? Centripetal force is perpendicular to the direction of the object's velocity. So bila dia perpendicular, kalau kamu dapat cos 90, it is equal to 0. So no work is done by the centripetal force because there is no displacement in the direction of force. Okay, you remember kita ada work F as cos theta. Okay, so bila dia perpendicular, contohnya sekarang force kan ke sini, velocity kan ke sini. Though dia perpendicular, dia tiada work lah dan sebab sekarang force ke sini. Tapi velocity pula pergi perpendicular dengan dia. So no work is done. Alright. Okay, for now let's look at the forces in uniform circular motion. So they will be horizontal motion, vertical circular motion, and I think there's a pendulum bob. Pendulum tu, oh yalah. So basically there's horizontal motion and vertical circular motion lah. Yeah, conical pendulum tu sama juga lah yang masuk. Okay, so now let's look at the horizontal motion. Okay, so for forces in UCM, you have to also be able to draw the free body diagram lah. Okay, so for this, all of this, I'll be drawing the free body diagram. And I expect you to be able to do it lah. Okay, so an object revolving in a horizontal circle with a constant speed. So if we were to draw it, we will be drawing it. So mata kita tengok begini. Yung mata. Yung mata ko juga tu. Okay, so kalau kita lukis, this is the ball, this is the string lah. So kiranya kita punya view sekarang ni macam ni. Okay, so kalau kita mau lukis free body diagram dia, it will be something like this. Okay, so we have the weight of the pendulum, bukan pendulum na ni, the ball. And then that is pointing downwards. And then we have the tension, just pointing to the left there. And then what else do we have? I think that should be it because there is no contact. So there is no normal force. So yes, so that is the free body diagram. So you have to draw it mg. Yang ini kamu kasi jadi dot lah nanti. That yang menunjukkan itu adalah object. Okay, so that is the tension. Right, so that is how you draw the free body diagram. Okay, lepas tu kita perlu buat for yalah. Okay, so now kita akan tengok for conical pendulum. Okay, so conical pendulum ni, it consists of a weight fixed at the end of the string lah, on the end of the string, ataupun rod suspended from a pivot. Then the weight is moving at a constant speed in a circle with the string tracing at a cone lah. Okay, so nampak lah di sini ni macam cone. Okay, so sekarang ni kita akan draw the free body diagram juga. So basically we are gonna focus on this view lah. Okay, so if kita lukis, kita akan dapat the tension is here, and then we have the weight of the ball. Bob kan ni, bob weight lah. Okay, and then what else? That should be it, right? Itu saja dia punya forces. Yeah, so kamu label lah mg. Then this is your tension, and then your angle is here lah. This is beta. Okay, right, so kalau kamu lukis tu, pastikan kamu lukis dengan betul. Right, so that is your free body diagram. Okay, then let's look at the rounding a flat curve. So this is bila kita macam kita limpas roundabout. Okay, kita driving, we wanna go through the roundabout. Let's draw the free body diagram lah. So again, the axis is gonna be at the object, and then we have the weight of the car. Remember, weight mesti sentiasa tunjuk ke bawah, lurus ke bawah. Jangan kamu pandai-pandai pergi begini ya, salah. Okay, lepas tu kita ada normal force sebab this tire is in contact with the road. So adalah normal force. And then to the ability of the car to round the flat curve is due to what we call static friction. Okay, so ada static friction between the road and the tire lah. So kita akan letak static friction ke sini, towards the center of the circle. Okay, so kalau kita label it, it is gonna be mg. This is your static friction. This is your normal force. Okay, so anything yang ada cars, kamu akan lukis the friction, the static friction, to be going to the center of the circle. Okay, towards the center of the circle. Right, so that is on horizontal motion. So ini yang kamu boleh expect lah time exam, you are asked to draw the free body diagram dulu sometimes. I mean, it helps juga. Kalau dia minta pun kamu lukis juga free body diagram. Okay? Okay, and then let's look at the vertical circular motion. Okay, so vertical circular motion, first one is roller coaster. Okay, so for roller coaster, kamu just boleh label terus lah di gambar ni. Okay, untuk point, the first one, untuk point di sini kita tengok. So since this human and this carriage is in contact, kita akan ada normal force dan kita akan ada weight lah. So ada normal force and kita ada weight. Lepas tu apa lagi? Kita ada, tidak, itu je. So basically this is your free body diagram lah. Okay, lepas tu kita tengok pula yang the second one here. So since both is pointing down, kita ada weight pointing down, lepas tu normal force pun in contact ke sini, because the badan tiba-tiba di kaki sini in contact ke bawah. So our free body diagram is both, the arrows is both pointing downwards. Okay, so itu kalau itu nantilah label. Untuk yang ini pula, untuk yang this one pula, this is going up and going down. Macam ni lah. Okay, so macam tu, this is your object. Okay, so kita label. Let's label them. Bella, gitu je lah. So if I label them, it will be G, and at point A, I label this as point A, B, point C. Okay, so and then this one is the G, and then this is NB, this is MG, this is NC. Okay, so that's why bila kita naik roller coaster ni, time kita berpusing, di sini ni kamu rasa mau jatuh sebab sekarang ni tiada forces yang buat kita rasa kita melekat dengan the carriage. Kita semua turun ke bawah because of the forces lah. Okay, the gravity is trying to pull us downwards. That's why kamu akan rasa macam kamu mau jatuh. Tapi memang mau jatuh lah, kalau kamu lepas tu safety belt, jatuh lah kamu. Gitu, alright? Okay, now Ferris wheel. Ferris wheel pula, same concept juga, sama aja pun actually. Tapi both the weight, the normal force sekarang ni semua di atas lah. Okay, so untuk Ferris wheel kamu lukis macam ni jalan macam biasa. Okay, ini pun sama juga. So this is your N pula, sorry. MG, this is your N untuk top. This is your N for bottom, this is MG. Okay, so kalau lukis nanti macam ni lah, the label and the drawing. Okay, so that is the Ferris wheel. Next, for mass attached to the end of a cord. Oh, ini sama juga nih. Okay, if you draw it, kita akan tengok from our eyes akan berada di sini. Gitulah. Okay, situ mata kita. So the ball is here. Okay, situ adalah kita punya dot ball representing the object. So this one is, kejap ah. Mass attached to the end of a cord. It's the same thing as the conical pendulum. Macam ni juga ba ni? Horizontal circle begini, kalau vertical mau begini. Okay. Kita akan tengok beginilah. Okay. So we have the tension. And then we have the salah lah, away from the object. Away from the object. Tension and weight is both pointing downwards. Okay, so kamu akan lukis tension and mg. Example number 2. A conical pendulum with a bob of mass 80 kilogram on a 10 meter long string making an angle of 5 degrees to the vertical. So we have to scratch a free body diagram and then calculate the tension in the spring, speed and the period of the bob, and lastly the radial acceleration of the bob. Okay, so we have to calculate the tension in the spring first. But firstly, we have to draw the free body diagram lah. Okay, so let's draw the free body diagram. So we are gonna have weight pointing down, and then we have tension. Okay, and then this is the angle. So this is mg, this is t, this is theta. Okay, theta aja lah, kita letak theta aja dulu. Nanti baru substitute the values lah. Okay, so that is the free body diagram. Make sure kamu lukis nanti tu, kamu lukis lah cantik-cantik lah. Tepe guna pembaris, guna lah pembaris ada masa tu. Tepa lah. Okay, so that is your free body diagram. Now let's calculate the tension in the spring. So untuk kita solve circular motion, we have to also apply uniform pula. We have to apply Newton's law of motion. Okay, so sekarang ni kita akan tengok untuk y component dulu. Okay, because kita boleh terus dapat the value of tension kalau kita guna y component lah. Okay, kenapa kita tidak mau guna x component? Sebab untuk cari x component tu kita perlu the acceleration lagi. Okay, kita perlu cari v lagi. Okay, so itu kita guna untuk the second one. That's why kita apply y component. Kita use y component dahulu. Alright. Okay, so that is equal to 0. Now t cos theta is t cos theta minus mg equal to 0 lah. Okay, so t is equal to mg over cos theta. So dapatlah tension 80 9.81 cos 5 degree. Okay, so dapatlah nilai tension which is equal to 788 Newton. Okay. Okay, next we have to calculate the speed and the period of the bob. Okay, so untuk the speed, tulis di bawah lah. Okay, so the speed of the bob, we can relate the speed with acceleration lah. Okay, remember we have acceleration, radial acceleration is equal to v square over r. Okay, so dari sini kita bolehlah apply, kita boleh look at the x component and it is equal to MAC. Okay, dia bukan equal to 0 sebab sekarang ni dia ada motion in the x direction lah. Okay, so sekarang ni total forces at x is just t sin theta. Okay, so t sin theta. Sekarang ni t sin theta is pointing to the left. Dia negatif atau positif? Okay, kalau bukan uniform circular motion, kita akan assume dia akan jadi negatif. Sebab sign convention kita sudah decide yang di sini negatif, di sini negatif, di sini positif, sini positif. Okay? Tapi sekarang ni, untuk UCM, which is uniform circular motion, kita akan tengok anything that is pointing towards the center of a circle. Mana-mana pun dia berada, kalau dia pointing towards the center of the circle, dia akan jadi positif. Okay? So, itu sign convention untuk uniform circular motion. Alright? Okay, so dari situ kita bolehlah start dengan kita bolehlah decide lah. So dia jadi positif t sin theta. T sin theta equal to mv square v square over r lah. Okay, so sekarang ni kita mau cari apa? Kita mau cari v. So kita boleh jadikan v, bolehkah buat di sini? Boleh lah. Okay, so sekarang ni kita mau V square dulu. So TR sin theta. Macam terlampau di atas pula, sabar ha. Boleh kah buat sini ya? Macam bolehlah, sinilah dulu. So V, kita mau cari speed kan. So V square is equal to TR sin theta over M. Okay. So sekarang kita ada T, kita just perlu nilai R. So what is the value of R? Okay, kita perlu find R. So macam mana kita cari R? Kalau kita tengok, actually kita punya motion of this pendulum bob ni adalah triangle. It is a triangle juga. Okay, so bila kita buat macam ni, ini adalah kita punya length of string. This is our radius. So we are looking for this radius. So kita lah bolehlah kita guna trigonometry. So kita ada, ingat tak? Kita ada toa cha. So sekarang ni dari theta ni, apa yang kita nampak? Kita ada opposite dengan hypotenuse. So kita boleh guna sin lah. So that is sin theta equal to opposite, which is R over the hypotenuse. So nilai R adalah L sin theta. Okay, so bolehlah kita substitute sekarang ni. Substitute. Okay, so dapatlah V square equal to TL. Okay, so ada sin theta di sini, ada sin theta sini. Kita just boleh sin square theta over M. Okay, so bolehlah kamu substitute dia punya apa tu, the values, and you should get the velocity to be equal to 0.865 meter per second. Okay, lepas tu pula kita perlu cari the period. So untuk cari the period, kita boleh guna the tangential punya velocity lah, which is the V yang kita calculate tadi. Find T, kita guna V equal to 2 pi R over T. Okay, so that is 2 pi L sin theta divide by, miring ka pula saya buat, divide by T. T ni bukan T untuk tension ha, ni T untuk period. So kamu akan dapat 6.33 seconds as the period. Okay, next we have to calculate the radial acceleration. So radial acceleration is just AC equal to V square over R. So that is L sin theta, then V square. So dapatlah centripetal acceleration there to be equal to 0.859 meter per second. Alright, so that is the solution for example number 2. Example 3, a car of mass 2000 kilogram car. So this is a car, runs a circular turn of radius 20 meter. The road is flat and the coefficient of friction between the tires and the road is 0.7. So we have to sketch a free body diagram of the car and determine the maximum car speed without skidding. Okay, so now kalau kamu ingat kereta, kiranya untuk yang macam ni kamu akan decide dia punya friction tu pergi kiri atau pergi kanan lah, mana-mana pun boleh, tapi yang penting kamu tahu dia akan jadi positive because it is going towards the center of the circle lah. Okay, so kita ada normal, and untuk car kita ada normal and weight and then friction lah. Okay, so I will be pointing it to the right. Okay, so this is, don't forget to draw the dot representing the car. So this is mg. This is your friction. So basically the friction that prevent it from moving is actually the static friction lah. Okay, and then that is the normal force. Okay, balik-balik. Okay, so itu adalah the free body diagram of the car lah. And then basically the center of the circle ni sekarang di sini lah. Macam tu lah. Okay, tapi lah tulis. Now baru kita boleh solve the maximum car speed. Okay, so untuk benda-benda macam ni, we always gonna look at both x and y component lah. Sebab memang dua-dua ni kita perlu supaya kita dapat solve the question. So first, let's look at the y component. So y component, there's no movement, so equal to 0. Jadi ini adalah n minus mg equal to 0. So n is equal to mg. Okay, lepas tu kita perlu tengok x component. Aduh, itu lebih. Equal to MAC. Okay, so that is Fs equal to mv square over r. So yang ni adalah mu n. Dia tidak bagi pula kan dia static atau tidak, tapi kita letak je lah F just to be safe. Safe apa? Rasanya betul je tu. Okay, so mu n is equal to apa? Equal to mv square over r. So sekarang ni kita perlu cari nilai apa ni? Kita perlu cari nilai v. V maximum dia lah. Okay. So kita perlu cari v jalan ni. Okay, so apa nilai n? Kita perlu substitute that into here. So kamu akan dapat mu mg equal to mv square over r. Now kamu perlu susun untuk v square, jadi equal to mu. Kejap, yang ini boleh cancel. So tinggal mu gr lah. Okay, kan? Yeah, alright. So sekarang ni kamu punya velocity will be equal to 11.7 meter per second lah. Okay, boleh lah. So untuk example yang ini, apa yang kamu perlu tahu is you have to decide sendirilah this direction of F is to the right ataupun to the left. Asalkan dia positif bila kamu kira nanti, sebab it is going towards the center of the circle. And then always start with y and y component is 0 lah actually. Tapi always consider both x and y component. Then baru kamu solve dia. Okay? Example number 4. A small remote control car with mass 1.2 kg moves at a constant speed of negative 15 meter per second in a vertical track of radius 3 meter. Kejap, kenapa ada negatif tu? It doesn't make sense. Aduh, actually ada negatif pula, typo guys. I'll edit the lecture note before I give you later lah. Tapi I need to add comment because I don't think I'll remember later. Mana comment? Kejap, sini comment. Typo. Okay, I have to remember that because nanti saya tidak fix dia. Okay, that is the comment. Kenapa saya kisah? Okay, lepas tu kita perlu calculate what? In a vertical track. Okay, dia ada bagi radius 3 meter, mass 1.2 kg, v 15 meter per second. Then we have to determine the magnitude of the reaction force. Okay, so n lah. Kita perlu cari n untuk exerted on the car by the track at point A and point B lah. Okay. So, kalau kita lukis, I'm just gonna draw it somewhere here lah. Sebab macam tak payah pun di sana. Okay, so kalau kita lukis, kita akan dapat, this is 4 point A. This is 4 point B. Okay. Alright, now, 4 point A, kita ada normal force and weight lah. And then, for this one, kita just ada For point B, it is the like that. Okay. Then okay, so that is the free body diagram, but don't forget to label them. So this is same carbon again. Yeah, same. So Mg, this is N for A, Mg, and N for point B. Okay, N is normal force ataupun reaction force. Okay, so after drawing the free body diagram, barulah kita boleh start solving the question apa. Okay, so now for this one kita just ada motion in the y component lah. So tak payahlah kamu pergi buat rajin-rajin mo pergi buat untuk x, sedangkan kita tengok y saja. Okay, so total force in the y component is equal 0 pula, MAC. Okay, so actually saya patut cakap macam ni lah tadi, lupa pula. Okay, sign convention untuk uniform circular motion, anything that follows the direction of radial acceleration. Okay, radial acceleration mesti positive. Okay, so radial acceleration dia ni, inilah, ini radial acceleration dia. Okay, so kalau the forces follows the direction of radial acceleration, it will be positive. Okay, okay. Apa? Okay, betul lah. Astaga, confused. Okay, so now bolehlah kita start jawab dia. So this is NA follows the direction of the acceleration, radial acceleration, so they're positive, minus mg equal to mv square over r. Okay, so the normal force at point A is equal to mv square over r plus mg. Okay, so it is equal to 102 Newton. That is for point A. Untuk point B pula, do the same thing. 4 point, tak payah pula. Just letak B. Okay, so kita refer yang inilah. So, both are positive sebab both follows the direction of radial acceleration. So, this is NB plus mg equal to mv square over r. Okay. And then we dapat mv square over r minus mg. So the reaction force at point B is equal to 78.2 Newton. Okay, so itu cara solve example number 4. Okay, same thing for this one here. Tadi kan saya cakap semua yang towards the center of the circle positive. Tapi betul lah, it's just easier if you know that if the forces follows the direction of the acceleration, radial acceleration, dia akan jadi positif lah gitu. Okay, kalau kita ada bola di sini pun, dia akan ke sini juga. Okay, so that is the direction of radial acceleration. So anything that follows the direction of radial acceleration will be positive. Okay, so that is example number 4. Right, example 5, our last example for this chapter. A ball of mass 150 gram is attached to one end of a string of 1.1 meter long. The ball makes 2 revolutions per second in a horizontal circle. So the ball is making a horizontal circle macam ni lah. And then we have to draw a free body diagram. Since no image is given, no diagram is given, you can just directly decide lah tension tu mau pergi kanan ataupun pergi kiri. So kati asalkan you know that anything that follows the direction of radial acceleration will be positive. Okay, so that is T, this is mg. So let's draw the radial acceleration is that way. Okay, so center of the circle sini lah gitu. Okay, now we have to calculate the centripetal acceleration of the ball. So given in the question is the mass 150 grams. So it is 0.15 kilogram. And then we have the length, which is 1.1 meter. And then lastly, 2 revolutions per second. So what is that? That is frequency. It is 2 hertz. Okay, ingat ka, frequency is the number of revolutions untuk dalam satu saat. Okay, so that is frequency. And then we can then calculate the centripetal acceleration by using v square over r. Tapi sekarang ni kita tiada nilai v. So we have to find v. We are gonna use 2 pi r over t. Itu yang kita akan guna. Okay, so lepas tu macam mana pula kita relate dengan frequency? We know that f is equal to 1 over t. Remember, f is equal to 1 over t. So dapatlah 2 pi rf. So dari sini kamu akan dapat the velocity, which is equal to 13.8 meter per second. So dapat tu barulah kita boleh substitute here. So kamu akan dapat the centripetal acceleration to be equal to, oh, I forgot to square this. This is 1.1. Kejap. A ball of mass is attached to one end of a string. O horizontal circle ba? Ini bukan length. This is the R. Okay, sebab kalau macam ni, actually dia ada gambar ba ni? Cuma saya tidak letak dalam nota. Should I just put the picture later? I guess I should, right? Okay, ada tangan lah di sini kasi pusing dia. So the ball is di sini. Yang saya lukis di sini. Okay, so the string ni 1.1 meter. Okay, tapi nanti saya add gambar dia. Okay. So the centripetal acceleration is equal to 173 meter per second lah. Okay. So again, please remember that the radial acceleration should be towards the center of the circle. Alright, next we have to calculate the magnitude of the tension in the string. Yang ni kita boleh lah guna Newton's law of motion. So total force at x mesti equal to MAC kan. So kita perlu cari tension is equal to MAC je lah. MAC. So it is equal to 26 Newton. Okay, itu sahaja untuk example number 5, and that is the end of our chapter 5. Lecture videos for chapter 5.